video, we're going to look at the graphs of quadratic functions and some features of them. The general format for quadratic functions is the following: a number times x squared plus a number times x plus a number. And you will recognize this format if you've worked with the quadratic formula. It is used in the same way, and that will be important for some of the features we're going to look at. Some things we need to realize about quadratic functions: these are all parabolas, and there is a location where this parabola either bottoms out or maxes out, and that location is called the vertex. Another feature of these is these are symmetric to a vertical line. And my drawings may not be all that symmetric, but they're supposed to be symmetric to a vertical line. We call this the axis of symmetry. And the vertex lies upon that axis of symmetry. So these are the things we're going to look at. We're going to look at finding the axis of symmetry and the vertex. We're going to determine the domain and the range. Of our function. We're also going to determine the zeros and any x-intercepts. And we'll also talk about determine the y-intercept as well. Okay, so let's start off by looking at the axis of symmetry and the vertex. If you have an equation this format, and again y and f of x, same thing, and you want to find the axis of symmetry. Well, that is a vertical line, so the equation for it is x equals a number, and the way you determine this number that this is equal to is the formula negative b over 2a, where b is the coefficient of the x term and a is the coefficient of the x squared term, just like with the quadratic formula. Once you know that, then we can also determine the vertex. So generically, I'm going to say the vertex is a number, comma, number. I'm going to call the first number h, the second number k. So the way you calculate the first number is negative b over 2a. That's the first value of the vertex, because the vertex lies on this axis of symmetry. So the x values, of course, are going to be the same. To determine the k value, you're going to do f of negative b over 2a. In other words, you're going to plug in whatever number you got for this axis of symmetry into the equation for your x's. And you're going to calculate that for your y's, because again, y is the same as f of x. We're talking about functions. So you could also say the vertex is negative b over 2a, comma, f of negative b over 2a. Now, that's going to relate to the domain and range. Domain for a quadratic, that's all quadratic graphs, look something like this, something like that, without some kind of specific limitation already described for the domain, then the domain is going to be all real numbers for all quadratic equations. In fact, for all polynomial functions, the domain is all real numbers. The range, on the other hand, are the y values, and these are going to be kind of limited based on whether this graph is going facing upwards or facing downwards. If a is greater than 0, so if the number in front of your x squared is positive, then y is greater than or equal to this f of negative b over 2a, well, this k value. Okay, so if you have a parabola and you have your hk vertex here, your y values are going to be that value or higher. If instead a is less than 0, then y is going to be less than or equal to this value. So again, if your parabola is going down at this hk location, then your y values are going to be that value or lower. So let's see, some kind of a question you might be asked to do. So find the axis of symmetry, vertex, domain, and range. Okay, so they give us a function f of x equals negative 3x squared plus 6x minus 1. Okay. And let's also say we want to sketch the graph. We'll put that in there using this information. So I'm going to start with the axis of symmetry. So this is going to equal negative b over 2a. So negative, my b value is 6, over 2 times my a value is negative 3. So that's going to be negative 6 over negative 6, which is 1. So my axis of symmetry is x equals 1. My vertex, well, since I know what the axis of symmetry is, I know my vertex is going to be 1 comma something. And so to find out what the y value is, now that I know what the x value is, I substitute that in to my equation. So negative 3 times 1 squared plus 6 times 1 minus 1. So negative 3 plus 6 minus 1 is 3 minus 1 is 2. So my vertex is at 1, 2. And I can actually go ahead and sketch this picture at this point with this information. So 1, 2, that's the vertex, that's the turnaround spot. That's my axis of symmetry. Okay. And then I know this is negative 3x squared, so I know my parabola is going to be facing down. So it's going to look something like that. Maybe a little bit more nice curve, but you get the idea. Looks something like that. All right. Now I'm going to find my domain and range. Domain, all real numbers. Every parabola, and let every quadratic function is going to be all real numbers. It goes left and right as far as I want it to. So all real numbers. Range. Well, looking at my picture, this has a highest value of 2. Right? This is at 1, 2. The highest value of 2 for the height, and then it goes down. So my y values are going to be less than or equal to 2. And there it is, domain, range, axis of symmetry, vertex. These are all kind of related to each other. So, you know, if you're going to find one of them, you're going to probably find, you know, if I want to find the range, I'm probably going to have to find the axis of symmetry and the vertex in order to do that. All right, so let's move on to zeros and x-intercepts. So, to find a zero of a function, set the function equal to 0 and solve for x. To find the x-intercepts, make y, or in other words, f of x, equals 0, and solve for x. Write this as some number, comma 0. And maybe I don't want to put that because we're using a's and b's. Let's say alpha. Alpha is comma 0, so not a, alpha. Well, you know, if I'm going to set the function equal to 0, what that means is I'm making y equals 0. So these are basically the same thing. It's just for an x-intercept, it has to go to another step to make a point. Now, there is something we need to be aware of. Zeros can be non-real. X-intercepts must be real. Must be a real number. So you can have imaginary numbers with zeros, but you can't have imaginary numbers with x-intercepts. So find the zeros and x-intercepts. So let's say we have g of x equals x squared minus 6x minus 16. So what I'm going to do is I'm going to set this equal to 0. And I'm going to solve this quadratic equation. So there's, you know, again, ways to solve quadratic equations: factor, take roots, complete the square, or formula, quadratic formula, right? And of course, some of these are going to work. I mean, quadratic formula is always going to work. Completing the square is always going to work. Taking roots may work, or you might have to complete the square to make it work. Factoring, sometimes they can factor, sometimes they can't. If they can factor, and this is the way I would approach the problems, maybe. I mean, I don't know, completing the square, we probably don't do that a whole lot, but these other three, I'd probably factor first if I could, and then see if I could take roots instead, or use the formula. In special cases, I might complete the square. Most of the time, I probably wouldn't. But this one does factor. Factors of 16 different by 6 are 8 and 2. You know, different signs, bigger one's negative. Set each of those equal to 0. So x minus 8 equals 0. X plus 2 equals 0. Add 8. So x equals 8. Subtract 2. X equals negative 2. These are the zeros. So if I say give me the x-intercepts and you say 8 and negative 2, you're not giving me the x-intercepts. You're giving me the zeros. But these are related to the x-intercepts because the x-intercepts are 8, 0 and negative 2, 0. X-intercepts are points. Zeros are just values. So there's that connection between those two. Now, let me do another one of these. So find zeros and x-intercepts. All right. So let's say we have h of x equals 2x squared minus 3x plus 7, let's say. Okay, and so I'm going to set this equal to 0. 2x squared minus 3x plus 7. And well, doesn't factor. Oh, okay, that's fine. Remember, that's not the only option I have. So it is a quadratic. A is 2, B is -3, C is 7. I'm just going to use my quadratic formula. Negative b plus or minus b squared minus 4ac all over 2a. I'll start putting my numbers in. -3 plus or minus -3 squared minus 4 times 2 times 7. Everybody over 2 times 2. And I'm going to start cleaning this up. Let's see what we got. 4 plus or minus. Oh, whoops, not 4, 3. Getting ahead of myself. Let's try that again. 3, 4 down here. That's what I was looking at. 9. Negative times a positive is going to be a negative. 4 times 2 is 8. 8 times 7 is 56. So this is going to be 3 plus or minus the square root of negative 47 over 4, which means my zeros are 3/4 plus or minus the square root of 47/4 I. Those are my zeros of my function. Zeros. And my x-intercepts are none. Don't have any. Because these are non-real zeros, I don't have any x-intercepts. I still have zeros, but I don't have x-intercepts. So sometimes people might look at a graph using a graphing utility to try to find the zeros of a function. And in that previous example, you know, if I looked at the graph on a graphing utility and I found out, oh, it crossed at 8 and -2, that would tell me the zeros. So, you know, sometimes you can actually, you know, especially if you have a graphing utility, work this way. You know, use an x-intercept to find a zero. Though the more typical way is to use the 0 to find the x-intercept. But as this one shows you, you know, this graph, what's happening here, let me draw like kind of a rough picture here, is you have these things and, you know, this graph is doing something like this. It's never actually making it to the x-axis. That's what this is telling me. It's saying, oh, you know, if I want to figure out where this is 0, where they hit 0 at these complex, these non-real numbers. So there aren't any x-intercepts on my normal graph here. So, you know, that's not going to happen. All right. Last kind of thing here I want to mention is just a reminder, y-intercepts. We make x equals 0, and solve for y. In the case of something that looks like this, and again, this could be f of x or g of x or whatever, then the y-intercept is going to be 0. Anything with a 0 is going to disappear, and it's going to be this constant, 0 comma c. More generally, the y-intercept is 0 comma f of 0. You know, but in the case of a quadratic, this constant value is telling you what that y-intercept is, and then you can kind of compare that to, you know, a line. The y-intercept for this is 0 comma b. So, and in fact, for any polynomial, the constant term, assuming everything's multiplied out, combined like terms and everything, that constant term is going to be the y-intercept. So let's do a problem where we do all of these and graph it. So find A, the axis of symmetry, B, the vertex, C, domain, D, range, E, zeros, F, x-intercepts, G, y-intercept, and then graph. Okay, so let's say we have k of x equals negative x squared plus 4x minus 1. Okay, so start with the axis of symmetry. Again, this is negative b over 2a, so negative 4 over 2 times negative 1, negative 4 over negative 2, so 2. So x equals 2 is my axis of symmetry. So B, vertex. I know it's going to be 2 comma something. Let's find that something. So k of 2 equals negative 2 squared plus 4 times 2 minus 1. Order of operations, you square, then do the negative, so this is going to be negative 4 plus 8 minus 1. So 4 minus 1, 3. 3. Okay. Domain, again, all real numbers. D. So this parabola is facing down. So because of that, it's going to be y is less than or equal to, and then I look at the vertex, 3. So that's the highest point it's going to reach is 3. It's going to be less than that. This is the maximum. You can look at that. It's a max. This y value. Max. E. What are we doing? Zeros. So we're going to set this equal to 0. Negative x squared plus 4x minus 1. Don't like that negative there. So why don't we just change all the signs? Multiply everybody by negative 1. 0 times negative 1 is still 0, so that doesn't change it. Non-factorable. So I'm just going to go ahead and use the quadratic formula. Negative 4 plus or minus negative 4 squared minus 4 times 1 all over 2 times 1. So x equals 4 plus or minus, there's a 2. By the way, this negative b over 2a is the front part of this quadratic formula. So 4 divided by 2 is 2. And that would have given me the b value. So that is a way you could, I mean, we could have found the zeros, since we were going to have to use a quadratic formula in this problem. We could have found the zeros first and then said, oh, well, I got 4 divided by 2. My b value, or, you know, my x value of my vertex must be 2. So that's the way you can do it. 16 minus 4, that's square root of 12. 12 is 4 times 3, 4 times 3. So this is 4 plus or minus 2 root 3 over 2. So my zeros are 4 divided by 2 is 2, plus or minus 2 root 3 divided by 2 is root 3. And my x-intercepts are 2 plus root 3 comma 0 and 2 minus root 3 comma 0. Now my y-intercept. Getting ahead of myself. Y-intercept, wait. If all your x is 0, 0, 0, negative 1. All right, so now I'm ready to start drawing some graphs here. 1, 2, 1, 2, 3. Okay, there's the vertex. -1, 0, -1 is that. Maybe I want to put these in my calculator just to get a decimal approximation. 2 plus square root of 3. This is about 3.7 comma 0. 2 minus the square root of 3. That's about 0.3 comma 0. So, you know, maybe about a third of the way there here, and then 3, 4, about 2/3 of the way there. I also know another point. I know this point right here. And this has to do with, again, that axis of symmetry here, that there's got to be matching points on other sides of this. So, I'm probably going to draw this pretty poorly, but, you know, something like that. I can't draw very good curves on this program here, but, you know, something kind of like that. That's my problem. So there's all those different features in here. Let me just kind of put all that information all in one spot. But if you have something like this, axis of symmetry is x equals -b over 2a. The vertex is -b over 2a, comma, f of -b over 2a. The domain, all real numbers. Range is going to be y is greater than or equal to f of -b over 2a. If a is greater than 0, y is less than or equal to f of -b over 2a. 2a. If a is less than 0, the zeros can be found by using the quadratic formula. Doesn't mean you have to. You can factor it, take roots, whatever you want to do. X-intercepts. If b squared minus 4ac is greater than or equal to 0, if not, there aren't any x-intercepts, but if there are, if that is true, then again, you know, whatever the zeros are, and again, you don't have to do it using the quadratic formula, but, you know, if you have this, this is always going to work, and y-intercept will be 0, comma c. So there's all the information kind of using that format, different ways you can find that, and that's an introduction to quadratic functions, the graphs of them.